In second lecture, I am going to tell you about compound interest. Compound interest, as you know, the formula is equal to S is equal to P1 plus I to the power of N, where I is the annual rate of interest. Suppose amount P has been invested or borrowed for certain number of years and interest is compounded at certain times in a year. That means it is not being compounded after a year as we discussed in our last lecture. If it is being compounded in a year, then N is 1. Suppose within a year interest is compounded twice a year. Interest is compounded twice a year. Twice means 2 times in a year. If it is 1 year, it is being compounded after every 6 months. If it is being compounded 4 times a year, that means if it is 1 year, 1, 2, 3, 4, it is being compounded 4 times a year, that means quarterly or after 3 months. 2 times a year means after 6 months or semi-annually. If it is being compounded 12 times a year, 12 times a year means monthly or after every month. Again I will repeat, interest is being compounded yearly or semi-annually or quarterly or monthly. In this case, we are required to know what will be the amount. In such a case, what we do, we convert our time frame according to the requirement. In this, our time frame was 1 year. In this, our time frame is 2. In this, our time frame is 3. In this, our time frame is 12. That means, to put it in very simple terms, we want to know what is the annual rate of interest. We want to know the number of conversions period in a year. That will help us to know the rate of interest per conversion period. Annual rate of interest is R. Number of conversions is equal to M. Rate of interest per conversion period is equal to I. And our total N is the total time and it becomes M into T, the number of conversions, and T is in the years. Now, putting these values in this given formula, we'll get the new formula S is equal to P 1 plus R by M to the power of MT. That means the compound interest S at the end of T years at the annual rate of R compounded m times a year is given by S is equal to P 1 plus R by m to the power of mt. For semi-annual, it will be m will be 2. For quarterly, m will be 4. For monthly, m will be 12. M is equal to 12. M is equal to 4. And in this case, m is equal to 2. Let me take a question. Question is, find the compound amount of rupees 10,000 for 5 years invested at 8% converted annually. Annually means S is equal to 10,000 1 plus 8% 0.08 to the power of 5, which is 10,000 1.08 to the power of 5. We don't need to calculate it. In your books, at the end, some tables are given. See table 1. The values of interest are given for the given rate of interest for the given time. The table 1 amount at compound interest. Periods are given in rows and interest values are given in columns. So we will look for the rate of interest 8%, that is 0.08. 0.08 at the value 5. 0.08 at the value 5 is 1.4693. We can take the values till 4 decimals, that is 10,000 into 1.4693, which comes out to be 14,693 rupees. Now same, I want to calculate if interest is being compounded quarterly. In this case, m is equal to 4. I is equal to R by m. So I is equal to 8% divided by 4. This would become 2% or 0.02. T is 5 years. So m into T is 20. Putting it in the formula, S is equal to 10,000 1 plus R by m. This is R by m. 1 plus 0.02 to the power of mt. Mt is 20. This is 10,000 1 point. Let it remain 1 plus 0.02 to the power of 20. Now we'll look for the values from the table 1. 2% in the column and 20 in the row wise. Again, I'm opening the book. Since it's given S is equal to 1 plus I to the power of n, so I is 2%. I is 2% and n is equal to mt, which is 20. So this is just look here. This is I is equal to R by m, 2%, and n is equal to mt, which is 20. The value is 1.4859. So 10,000 into 1.4859, which comes out to be rupees 14,859. You need to have an understanding of this formula. Only then you will be able to do questions on annuity. So please practice it. Another concept is when interest is compounded continuously. You are also required to know that formula when interest is compounded continuously. S is equal to P 1 plus R by M to the power of MT. We will limit it, and the formula which will, you are not required to do derivation of any formula in this paper. So S is equal to P E to the power of RT. The value of E is again given at the back in the table. So just put the values and say it. Let me do one question on it. Suppose a person deposits rupees 5,000 in a bank which pays interest at 11% per annum for 10 years, and interest is compounded continuously. Just look for the keywords in the question. If it's given compounded continuously, that means which formula you are going to use? You are going to use the formula S is equal to P into E raised to power RT, which is equal to 5,000 is E and 11% for 10 years, which is 5,000 E 1.1. Take log on both sides. Log x is equal to log 5,000 plus 1.1 log e. You know the value of log e. Log e value is 43 plus 1 log x. Since there are 3 zeros, so it will be 3. The decimal will be put after 3 values. 3 point. From the back of the book, the log table is at the back of the book. Log table is given. We will look for the value of log 50 at 0. Let me take the book. Log 50 logarithm table, add 0 and 50. The value given is 0.6990. So 3.6990. We multiply the value, take the anti-log. S is equal to anti-log of 4.1767. Answer is rupees 15,020 approximately. So this is how you compute the interest. Now in the question might not be so simple in the exam. In the question, you will in the examination you will get the question where interest is being compounded for different years at different rate of interest. Say in the first 2 years interest is being compounded annually. In next 3 years, interest is being compounded semi-annually. In the next 5 years, interest is being compounded continuously. The total time period is 2 years, 3 years and 5 years. So total time period is 10 years, and you are required to know what will be the amount at the end of 10th year. So in this case, you have to compute the values at different with different calculations. Let me see if there is any such question. We can do it. Yes, there is a question, and it is come in the examination also. The question is, Mr. X deposited rupees 10,000 in the bank for 3 years at the rate of 6% compounded half yearly during first year. Then at the rate of 12% compounded quarterly in second year and 10% compounded continuously during third year. Find his balance after 3 years. Nothing to worry. You know the formula. Put the values in the formula and calculate it. For first year, it's 1 plus 6% divided by 2 to the power of 2 into 1. For second year, it is 1 plus 12% divided by 4 to the power of 4 into 1. For third year, it is e to the power of 10% into 1. So this means 1 plus 0.06 divided by 2 to the power of 2. This is 1 plus it will be 3%. So 0.12 by 4 to the power of 4. This is 1 plus 0.03 to the power of 2, and this is will be 1.43 are again 12. Yeah, 1.03 to the power, but time frame would be 4, and this would be e to the power of 10%, which is 0.1, so 0.10. Putting in the formula, first year, second year, third year. So S is equal to P, that is 10,000, 1 plus 0.03 to 1 plus 0.034 e to the power of 0.10. Now just see the values. The base is same, and if the base is same, then powers can be added. 10,000, 1.03, 2 plus 4, 6 e to the power of 0.10, 10,000. This value can be seen from the table. Let me see the value. First table, 3, what we'll see? We'll see 3% at the top and 6 in the end. Table 1, 3%. Yes, here is the 3%. Yes, here is 3% and end. 1.666, 1.1940. 1.1940 and e की भी वैल्यूज जरूर गिवन होंगी टेबल में. e to the power of 0.10. let me see, here it is, e table, e here table 5, ex, e raised to power minus x, and x is 0.10, 0.10, it is 1.1052, 1.1052. let me check with the values given in the answer. Yes, it's the same, 1.1940, 1.1042. So multiply all and the answer is 13196.64. So this is how to calculate. So in this lecture I have given you the formulas for compound interest when being compounded yearly, semi-annually, quarterly or monthly. Means it is being converted into number of times within a year. So formula is S is equal to P 1 plus R by M to the power of MT. Second topic which we have done is when interest being compounded continuously, and third, when interest is compounded at changing rates. So practice the questions given in the book, because it should be on your tips. You should be able to calculate it very fast, how it is being changed and which formula to be used where. Thank you.